You can even get more information than what the vendor wants you to know from this. I mean, you can know when the developers are actually having their shifts from the modification time, for instance. So now I hope you have a structure in mind in how to analyze this data. And if not, if we are still stuck at this point, we can also use simple text or binary forensics. Intuition matters. Strings is your friend. Just look for common usernames, common strings, operating system names, software names. You will see many times JCC appear, for instance, and launch your hexadecimal dumps. And here, I couldn't find any automated tool for doing this, to sort out strings by relevance level and get more information than just analyzing the known data. But I'm trying to write one at the moment, and I'm going to give you a demonstration right now. I'm going to show you a Netgear firmware, which had the particularity to be from the same model as this. It's a wireless router, WG602, which had so far 3 different advisories on Bugtrack. One in 2004 with a hard-coded username for administrative access. Another password the same day. And 2 years later, same mistake. So let's have a look on how to identify this. We're going to use first an hexadecimal dump on this. I have no screen here, so please bear with my spelling mistakes. First one, okay. So I'm going to use x60 for this and pipe it through my least favorite pager, but whatever. So what do we have? We have a bunch of random data. But we can already see here the string header 0. Okay, why not? And even piggy. So there's a small piggy inside your wireless router. But for the rest, I can be only sorry there's nothing interesting here, apparently. So let's look deeper. Let's ask strings and be as lazy as just letting this give you more information about it and accept, yeah, this is not really helping much, is it? Strings actually matches any printable characters from 4 characters long. And I can scroll as much as I want, and I still don't see anything relevant. Okay. So now let's use my tool. So I developed a small tool, which is basically trying to match patterns inside files, just like file does, except file will just tell you its data. So the difference is I look from any potential offset in this file. And what's the result? Okay, lots of false positives apparently. I'm even going to use my latest version, which should look a bit nicer. For your pleasure, yes, with scoring information. So the first match is JZip here, and it's 100%. Which looks quite good. It's at offset 28. So we're going to have a look at this later. And we can see that the rest doesn't look very interesting. Like we have CPIO and JZip signatures, but this doesn't look very interesting. And we can eventually have a look at this one, for instance. So let it be more verbose about it. So it was offset, I think it was, yes, it was this one. So the compression method advertised is not in a standard. We have some known flags, which is a good start. The date could be actual, even if it's a bit early for this model. And the operating system is not registered. This doesn't look also good. If you look at the next one, the date is from 1964. So I don't know if anyone designed firmware images for this router in 1964, but he was obviously very clever. He should be the next religious personality or something, the next prophet. Anyway, let's have a look at this first signature that we matched. So I'm going to use DD, which is very useful for lots of stuff, including this. So no, not on my executable, on the firmware image, please. And we're going to pipe it to standard outputs, ask it to have a block size of 1 to allow us to skip exactly 28 blocks of 1 byte. We pipe it to gunzip, the regular one, and to the pager. Oh, okay. Thankfully, my pager is escaping escape characters for me. But I think it's going to be easier if we use, once again, an hexadecimal dumper. So we have zeros. And I like it, because it certainly means that the encoding was meaningful for gzip. We have a bunch of, oh, data, okay. More data, more data. Yeah, well, this is not looking any readable right now. Okay, so once again, let's use strings and be the laziest persons in this congress. Okay. Okay. Oh, what's this? Can someone identify anything in this? Oh, I think this is fairly understandable. Linux version 2420. How many advisories on this one? And we even have more information about the software they use to compile it. So we can even have information about the systems the developers used. It's here saying GCC 323 with some modifications.
You do a search for IP tables?
Oh, yeah. Not matched. What should I look for?
MTD is enough for Harald.
Okay. So they use Linux, and we even have some symbols. Of course, we have the strings. You can even see some insults from the Linux kernel, but that's not the point. We already have the source code anyway. So that was for the demonstration. I encourage you to continue at home and have fun. And the lesson is vendors never learn. Now, more identification. And let's go back to full screen for your visual pleasure. So, executable formats first. What do we have? We have mostly portable executable for the Windows world, and ELF for the Unix world. And actually tend to be reused, because this is very complex to design. It's fairly useless to redesign, considering what's already available, and the number of tools which are already supporting it. So I would say it's fairly exhaustive if we just have a look at portable executable and ELF now. And portable executable is actually inspired by Unix COFF and still compatible with MS-DOS 2. I'm saying 2. It's not a spelling mistake. And if you say, but Windows is not portable, why is it called portable executable then? Well, Windows is not just XP or 2000 or MS-DOS 2. It's also Windows CE, and Windows CE runs on a number of platforms, including big engine platforms, just like NT4 was also running on alpha machines. And it's used for not just executables, but also libraries, device drivers, and even screensavers. So the file format is looking like this. You have first an MS-DOS 2 header, which is nowadays waste, I think. Then you have more waste. You have some information about the vendor. Then you have finally the offset to the actual header. Then you have more waste, a stop program to say this program cannot run. More waste. And finally, what we are looking for, the actual header with the extra stuff. The actual MS-DOS header is looking like this. So we have magic. It says MZ here, always, whatever happens. And you can also look for this program cannot be run in DOS mode, because the compilers always include this by default. So I don't know any, I mean, if I were a developer for a company, I would not bother remove this, so I guess nobody does. So look for this, and look for this offset here, which tells where to look for the PE header, which is looking like this. We even have more magic. This is always 5045 0000. This is always 0. This is always 0. You can also look at this offset, which is meaning this is a file for i386 platforms, P32 executable. The linker used was version 7, which is appearing here. So you can guess which version of Visual Studio they used. The entry point is here, if you want to run it inside an emulator or further debug the application or disassemble it. And this is more version fields. One is for which Windows version is required to run it. Here it's Windows NT 4. And with which version of Windows it was generated. 5.1 is Windows XP, if I'm correct. So that was for PE. Now let's have a look at ELF, which looks almost the same, except it's just simpler. It's just a series of sections. And it's even easier to spot because it says directly in the first 4 bytes, 127 decimal and ELF. Just a list of sections, a program header table, section header table, strings packed together, fairly easy to recognize. And the best way to know about this format is actually to read the C definition. So if you're familiar with C source code, this is the way you're going to be reading it more efficiently, just like PE. It's a pain to do it manually, so write tools, use tools, and look for this kind of information. Try to fill it and see if it makes sense. Here you have 16 bytes just about metadata, the magic, for the first 4 bytes. And you have even more information here about the machine used, the versions, types, more flags, entry points, number of sections, which is also some kind of redundant information. So with a very efficient program and lots of computing power, we could probably guess it, even if we didn't have this format, this definition, I mean. Okay, now, let's skip to some more low-level stuff with some processor architectures. I will speak a bit about x86, of course, because you all have one, I think, even in your brand new Macs now. And if you happen to be a gamer or using circuit boxes, it's also all running x86. It's only little endian, so when you read, if you see some binary data which is longer than 1 byte, reverse it and see if it makes more sense. We know from the bootloader slide, the standard boot process, 512 block with a given signature and some stack initialization instructions, which are also present in the FAT file format, because it doesn't start after the bootloader, but actually inside the bootloader, because every partition is bootable. And that's not just one way to boot an x86 machine. Some x86 machines have firmwares for years now, just like Cobalt racks in your provider's former data centers. And now we have open firmware and new stuff coming. We can identify it directly from the assembly. You can see a fair amount of instructions which will be looking like this. 5589E5, which is stack code when you change from function to function. And when you leave the function, it's going to be C9, C3. So if you look for just this magic and look for the patterns in how it appears, how sparse, and like since the next function should start after another one, this should be right before this all the time. And if you happen to see data containing this pattern, you can guess that it's x86 assembly with a fairly good estimation. Now ARM, or Acorn RISC Machine for the full name. It's used in lots of embedded systems. I even have one in my pocket here. I think so, yes. Nosaurus, it's a complete machine with an ARM processor. And of course, it's running Linux and has firmware images downloadable. and you can replace it and play with similar